Okay, so good morning or good afternoon or good evening, depending on where you live. So I'll talk about the difficulty to relate the timbral qualities of a bowed string instrument with its acoustic properties and construction parameters. So let me present briefly the context. So it's been a long-standing goal in musical acoustics to identify for a given individual musical instrument relationships between the timbre as evaluated by players and listeners compared to other instruments of the same family, and its structural and acoustic properties. In case of the violin families, there's been over a decade of perceptual tests conducted by like Harry and myself and another PhD student, Indiana Woolman. But overall, there were quite only a few clear-cut results. Why? First of all, players and listeners hardly agree among themselves. And secondly, any two given instruments differ by so many parameters that it is hard to know what perceived quality is due to what acoustical parameter. And so that's why I've been involved in two international projects which were designed to explore links between perceptual properties with construction characteristics and not only acoustical parameters, by building a set of violas and a set of violins with a controlled construction parameters. One is called the Obialto project. It was organized by a team of makers gathering yearly at the Violin Society of America violin making workshops in Oberlin in the US. And the other one is the Bilbao project, which was funded by Erasmus Plus and led by the Bilbao violin making school, Bele. So let me talk about the Obialto project. While the outline geometry differs slightly between violins, it can vary considerably between violas. And so that's why in the 2016 violin making workshop, a group of instrument makers have collectively designed the so-called Obialto outline. 25 violas were then built following this model, but only this constraint was the outline geometry, and were brought to the 2017 workshop, where I had the opportunity to record all of them. So I imposed that they were all restringed with the same set of strings to remove this, at least to have one less variable, especially that when you take sound radiation measurements, the strings are damped. And so I didn't want the strings to interfere while I would not be able to measure the influence. The detailed construction parameters were provided by all makers. And the two short excerpts that were recorded by a professional player working for a very famous dealer in New York, so very used to try instruments, were one in the high register and one in the low register. Can you hear? So they were made short because we wanted
Sorry, Claudia, sorry to interrupt. I think we're hearing the sound from your microphone, but not from the system. So you might want to try to reshare your screen and go to advanced settings. And I think there's an option there to share your system sound so that we can.
Where control advanced settings?
Share screen again, and I think at advanced settings.
Because so I should stop the share screening?
Yes, I think we should do that.
Because the thing is, like, I didn't see where I could.
So if you go advanced on top, it should be in the top middle. Can you see an advanced tab at share screen?
No, I can say stop video.
Look in the lower left corner.
Yeah, advanced tab.
I don't have advanced tab. I have plus.
At the top of share screen, you should have a basic, advanced, and files.
Okay.
Yeah. So if you click advanced and then low left.
No, sorry. Where is the advancing? I don't have it. I had no problem last time I used Zoom.
So if you click on share screen, you don't get three options on the top where it says basic, advanced, and files at the very top.
I have only one participant can share. I have options for advanced sharing, and there's nothing about sound. think I will have to.
We might consider just moving forward.
Yes, exactly.
and using a lower quality sound. I mean, it's audible. It's not particularly high fidelity, but hopefully we'll be able to hear a little bit of what you're referring to. I'm sorry.
I can't find it. And I don't know, usually I know where the option is. I don't have it right now. I don't know why. So the recordings were used in 2 listening tests, one for the low register and one for the high registers, based on the 3 categorization task. And 20 international makers took the test and 10 French violists. So we had makers and players. And I will just present some of the results because there are quite a lot. But so here you have the hierarchical tree that you get for the low register and for the high register. And we tried to look at the verbal data, all the comments made by the participants for the different groupings they did. And we managed to actually bring to light some shared properties between some instruments, where, for example, we had a group which were considered as rich, deep, bright, positive, this group more like a dark, positive, and weak. And so we identified a few groups like this. We did that for the high register. No surprise that they don't correspond because it's quite famous for players that the voice of a viola or a violin is quite different in the low register than it is in the high register. And it's all the problem for makers to actually make an instrument which sounds great in both registers. So no surprise that some instruments are weak in the dark register, but in the low register, but powerful in the high register, for example. But although we were able to find some shared properties and some consensus on how they describe the different groups, you can still see that the tree is very radial. And so there is not strong consensus about like strong groups of instruments. Nevertheless, because we found these attributes, some shared attributes, we thought, okay, can we actually correlate them to some audio descriptors? So we basically took the MIR toolbox as a Timbre toolbox and ran all possible descriptors on these recordings. And we didn't find anything except one slight correlation between the spectral centroid frequency and the brightness of these violins, but only for the extreme groups. So here you have the different groups of instruments, and we had one which is called dark negative, so probably like too dark, and we have one which is bright negative, so probably like kind of too bright and harsh. And here we see that you have low spectral centroid and high spectral centroid. Between bright positive and dark positive, it's very, very similar. So why that's a question? Because nothing else would correlate. We looked as well at links between radiation measurements, didn't find anything striking. We looked at construction parameters. I'm only putting here the top weight and the back weight of the viola. They are all over the place. And so the conclusion there are that there is a large variability among participants due to the high diversity of criteria. So people didn't agree on how they were labeling the different groups, and as well the complexity of the task, because actually it's very, very subtle differences between the instruments. Very few links were found with construction, and that's probably because the multiplicity of the parameters during the building process allow instrument makers to obtain a certain set of perceptual properties with different strategies. And that's why we designed the Bilbao project, where this time, instead of just imposing the outline, we actually controlled everything from the choice of wood to the choice of fingerboard bridges. We built 6 violins with everything as similar as possible, except a controlled change in thickness, either for the top or for the back plate. So we have always one plate, which is medium, and the other plate varies between thick, medium, and thin. So here you have the thick top, medium top, thin top, and here you have medium top, thin back, medium back, thick back, and the other plate being thin. We wanted to have a control, so the medium violin here was actually built twice to see whether the differences that we have at the end are due to desired change in thickness or because of the variability that we have because we are working with wood. To make them as close as possible, we used the new technology, which shows wood from the same piece of trunk. And we used new technology using CT scanning and CNC router to go from the CT scan to the file for the router is actually more tricky than it looks like. It took 2 years. Then we were able to cut the back plates and the top plates. After that, they were graduated for having different thicknesses from thick to thin. Then the boxes were closed, controlling all the ribs. We carefully selected 6 bridges among 50. We CNC routed the necks, which shows the fingerboards as well. And 2 years later, we managed to get the 6 violins plus another extra violins that were CNC routed, but then worked by external makers with a bit less constraints to have a larger variation. So what did we do with these instruments after that? We had a playing test based on free categorization with 21 players. And looking at the results for the 21 players was not very informative. So we looked at whether players could be divided into groups. And we found 2 groups which made interesting trees. This is the tree for one subset, 7 players. And which actually makes sense if we look at in terms of construction, because we have the thin top and the thin back together. We have the thick back and the thick top together, as if, having one plate, thick or thin, doesn't matter if it's the top or the back, it gives the same type of properties. And we have the 2 medium violins very close together. But for this subset, 5 players, you can see that one of the medium violin is very far from the other medium violin, and is actually quite close to one of the thin back, which is far from the thin top. And the thin top is far from the thick top. So very large disagreement and different strategies in terms of grouping these violins for the 2 subsets. We looked at the verbal data. We haven't been able to extract any information which could shed light on the differences between the different groups of violins for the different subsets, to explain their different strategies. And that's because of variability and disagreement. These violins were used in a listening test as well. In an auditorium, we had 65 participants. We did the test in different formats. One part was actually comparisons by triads. And in particular, we tried the 2 medium violin and the thin back. And we asked which 2 are most similar and which 2 are most dissimilar. Here are the results. That the violins which were considered the most similar and that the most dissimilar. And what is quite interesting is to see that here we have 29 people who thought that it was the 5 and 11, the 2 medians which were together, like subset 1. And we have 23 players, so almost the same, 3 listeners, almost the same number, which actually found that it was 5 and 13, like the players, the listeners in subset 2. And for the most dissimilar, we have the same. We have 29 people who actually thought it was 11 and 13. And that's because basically both subset 1 and 2 found that. But we have actually as well 20 people who thought that it was 5 and 13 together. And so you can see here the big disagreement, because you have 20 people thinking 5 and 13 are the most dissimilar. And you have 23 people thinking that 5 and 13 are the most similar. And so that's, that shows a large disagreement between listeners, but this disagreement was actually observed as well between players. So at least we have some agreement at some point. We had another triad tested, V1, V4, and V11, and nothing correlates with what the players said. So it's more complicated for other triads. And I will finish with just some quick results about the sound quality or the timbre, which when they were compared by pairs, which had the best sounding quality, the best timbre. And here we can see what they compared by pairs. We have here in the low register, here in the high register for different pairs where we associated a thin top with a thick top, a thick back with a thin back. And we can see that actually listeners did perceive big differences. So the question is not that they don't perceive differences. There can be quite big differences between the violins, but there is not necessarily agreement. And there is more agreement when you actually reduce the task by just comparing by pairs than by having more variability with more instruments to compare at the same time. So there were quite clear perceptual differences for listeners, which result from construction differences, which were not brought to light by the categorization task. And that makes actually strong conclusions for makers in terms of timbre, better to be on the thin side than on the thick side for your plates. So in terms of conclusions, I'd just like to raise questions that I would like to discuss with you is like how to get reliable information on the timbre of different instruments of the same family in order to relate them to acoustic and construction parameters when differences are quite subtle and multidimensional, and when players and listeners disagree so much. And the other question is like what audio descriptors to use when the musical content is more complex than just one note, and that listeners probably average over the musical phrase as the timbre changes from note to note. It actually changes so much that listeners cannot recognize it is the same violin if the notes are separated. Even at adjacent notes, you cannot say that they're the same violin if you hear two different notes from the same instrument. So we are interested in players' evaluation, so we need playing tests, but I've designed listening tests based on recordings because I thought that at least we could do some sound processing on the recordings and find link with perceptual properties, but not at all. As we did categorization tasks because we thought it was more supposed to be the most natural, but we haven't found any strong conclusions using them in our case because of the difficulty of the task. And then pairwise comparisons seem to provide information because it reduces the complexity, but then they are not necessarily in agreement with what players think when they have a larger group of violins, which is kind of similar to the problem known as joint versus separate evaluations. So lots of issues and feeling a bit stuck with all this complexity. So any feedback would be very appreciated.
Thank you very much, Professor Fritz. We're a little bit behind schedule right now, but we do have time, I think, for two quick questions. Matthew Zeller.
Yes, Claudia, thank you for your paper. And as a maker myself and a former participant of the Oberlin workshops, I applaud you for bringing makers into the discussion. A couple of questions. One big one is related to varnish. What was so first for the Bilbao experiment, were the instruments in the white or were they varnished? And
no, they were, sorry, I should have specified they were in the white because we didn't want to have any complexity with varnish.
Yeah, so reduce that variable.
Yeah.
So have you thought about reducing the variables further and rather than studying the plates, just look at bridges? So have the same instrument, same strings, same bow, same player, and just do 25 different bridges with different bridge thicknesses, different, with different shaped heart, different shaped kidneys, different thicknesses to the legs. There are all the variables that can be controlled.
Yes, I mean we've done that. The main problem with bridges is you can't have two instruments at the same time. So you have one instrument, you play it with the bridge, and then you have to change the bridge, yes. and then you don't have them at the same time, and so they can't be compared. And it's actually very, very difficult. We've tried to do it. There is a lot of variability just because the memory is short, and people would say, I would like to compare again. And by the process, you never can put the bridge exactly at the same place, and then it's
always going to be that problem.
And yeah, so we never know what is due to the bridge and what is due to all of the aspects. And the thickness, what comes from like a maker's perspective is like they would like to know whether if you have a top plate which is a bit thick, do you need to match it with a thick back, or you match it with a thin back to actually compensate for the thick plate, for example.
Yeah, I think neck angle is going to be a huge factor on this.
Yeah,
and so if the neck angles aren't all exactly the same.
They were. This was like very carefully controlled.
Okay. Okay,
Thank you,
we'll talk more about this sometime. I'm interested to talk more with you on this.
Yes, please. I will be here for doing the town gathering. So,
our next question is from Kai.
Yes, thanks, Claudia. That was very interesting. I mean, it seems to be that you're struggling with high inter-individual variability, right? So I wonder whether you have considered approaches of integrating some anchors into your perceptual experimentation. For example, in sound quality ratings, when it comes to evaluating different algorithms, say on speech quality aspects, people usually include really bad stuff just to make everyone be on the same page, in a sense. Have you considered strategies like these?
Well, I mean, for the Bilbao experiment, we couldn't really, because the point was to make instruments, you know, which only differ by one parameter. We thought that we had made quite extreme changes in thickness. So we thought that the thin was quite thin and the thick plate was quite thick. Not too extreme, because that ended up in very bad instruments. Though I agree with your point, to some other extent, players will be very unhappy. And when they're unhappy about an instrument, they will just say it's bad. Won't know anything about it. So we had to make them different enough to have differences, but not too extreme. Otherwise, players would just discard them. They are too bad. We thought they were quite different. Overall, we still feel in the end that the differences were more subtle than we thought they would be, which is informative for makers as well, but which doesn't help to probably have bigger differences and maybe larger agreement. But yeah, so.
Okay.
Thank you, Kai. And there is another question in the chat, but in the interest of time, I'm afraid we have to move to our final speaker of the session. But please join me again in thanking Dr. Claudia Fritz for this great talk. Our final speaker.